Hello all. In this lesson, we are going to look at area of a triangle, and in this case, this is not a right angle triangle. Let me label this as A, B, C. As you can see, the first triangle has an obtuse angle at B, the way that I have sketched this. Now I'm going to pull another one, which is ABC. Obviously, you can see just by your eyesight, the obtuse is now at C but not at B. What we are going to do is we are going to prove or probably obtain the equation of the area for this particular triangle based on the length ABC as well as angles A, B, C uppercase. Now I'm going to label exactly the same manner I did here. A for A, B for B, C for C. Now first thing, I'm going to drop a perpendicular line from B onto the AC. Let me take this height as H. Now if I know the H, I would rather write down area is equal to half times BH. Well, that's our normal equation for an area of a triangle. We know the base length B, but we do not know H at the moment in terms of ABC. Let's find it. If you consider this point as, let's say, P, ABP is a right angle triangle. Hence, I can apply the trigonometry to find the height H. And I know that H divided by C is opposite over hypotenuse, sine A. Therefore, I can write down H equals sine A times C. So C is in the front. And then we can replace H here, gives me the answer, half BC sine A. So that's my area for this triangle. Now we obtain the equation. What it means is if we given two sides and the angle in between, you can simply write down the area as half those products, the length products, times sine A. Would this work for the other triangle, you think? Okay, let's have a look at. I'm going to drop a perpendicular again, and I extend AC so that I meet the drop BP and AC at P here. Again, if you look at the height as H, the bigger triangle again ABP is a right angle triangle. Then you can apply trigonometry, and then again you can write H on C equals sine A. Then you multiply both sides by C to find H, which gives me C sine A. Therefore, you can notice, or you can see, it works for both triangles where I have obtuse angle at B here and then acute angle at B here. So it works nicely. Let's have a look at an example. Let me quickly draw a triangle, and then let's say I have length 7 centimeters here, 18 centimeters. Let's take the angle as 30 degrees to make our life easy in our calculations. Now the area is half BC. In this case, B and C are 7 times 18. Then sine the angle in between those two lengths is sine 30, and you remember sine 30 is in fact half. Therefore, we get the answer, 7 times 18, I just try to keep this one, 7 times 9 times half, because you get cancel this one as a 9. Therefore, the answer is 63 on 2 units squared. That's our answer for the area for this particular triangle. Let's say if I have another triangle, in this case I'm going to connect what we learned before in this red triangle to this particular case. Let's say I have been given exactly the same way 7 centimeters and then 18 centimeters, and then I'm going to look at another length, let's say 12 centimeters. Of course this forms a triangle. Now we don't have an angle to find the area, so let's say this angle is A. So how to find A? Well, keep thinking. Well, of course you're right, the cosine rule. So you can apply the cosine rule to find A. So how do I write? The opposite is the length 12, therefore you can write down 12 squared is equal to 18 squared plus 7 squared minus 2 times 18 times 7 cos A. Then you can rearrange and find A, or you can use the CAS simply to solve the A. Then you will find the cos A. Let's write down one more step here. Cos A is equal to 18 squared plus 7 squared minus 12 squared. Simple rearrangement, arithmetic manipulation here, and then you divide both sides by 2 times 18 times 7, and then that will give me the value for A for the first quadrant. That's what we are looking at, first or second quadrant in this case. Let's have a look at the CAS calculator and get the answer. So I typed in here, let me quickly move, 18 squared plus 7 squared minus 12 squared divided by 2 times 18 times 7, and then I have applied cos inverse because I have to take the cos inverse here. Then I execute here on the calculator. That gives me the value. In this case, of course, because my settings are in radians, it gives me radians, and then I'm going to change that to degrees and execute and see the number. That's 24.67 degrees. However, I'm not going to round off at this stage. I would like to apply my final equation, which is half BC sine A. Now in this case, if you look at your A, the BC are again 7 and 18. Therefore, let's apply that. Half BC sine A, so half times 18 times 7 times sine value of this one. I'm going to just simply copy and then pull it down to make sure that we have everything into account, or rather you can just type cos inverse that whole equation inside there to make sure that you get the exact figure. Then you press enter. Now we have the area as 26.30 square units to the second decimal in this case. So let's write down those two. 24.67 for this one, degrees as your A, and then the area is half times, in this case I should write down area, half times 7 times 18 times sine A, and then we got the answer as 26.30 if I remember correctly. Let's go back and double check though. Yes, all good. I think we got through these two questions. One is when it is given fully nicely the two lengths and then the angle in between. The other one is where you don't have the angle, where you have to find it. You have to use cosine rule to do that if all the three sides are given. So I hope you understood. Please work on the work plan, and I'll catch you again in another video lesson. Okay, bye for now. Thank you.